So this is a geometry lesson, and sometimes you will have an image like this where we have a right triangle. And notice that the leg, right, that's serving for a side of both of these triangles happens to be perpendicular. So it makes a 90-degree angle. Now, notice right here, the question was, name the shortest segment from point D to AC. Okay, well here's point D right here. And then AC is this line segment that's on the bottom. And I'm just going to highlight it real quick orange. Now the shortest distance is always going to be the perpendicular route, right? If you were to try to go down, what we would see is this is the hypotenuse of a triangle. If you were to go down this way to try to get to the line, right? I'd say that's the scenic route. It takes a long time to get there. It's going to be a longer distance. But the direct route goes straight into it and forms a perpendicular line. Now, with that being said, this one is really easy. We don't have to do any math. We just had to understand that fact. And so if we want to know the shortest distance from D, which is right up here, to this line down at the bottom, well, the shortest distance is this perpendicular line. That's 9 units. So what we can do here, when it says name the shortest segment from point D to AC, we can actually say it's DB, because that's the name of the line segment. Notice they didn't ask for the length, they just said name the shortest segment from point D to AC. So the shortest segment would be DB, this leg right here. So I'm going to go ahead and just box that answer. And remember that is equal to 9 units. But this is your answer. Now, the second question, it says write and solve an inequality for x. So looking at this, right, we want to think about this does create a right triangle because we have this right angle here. And I want you to remember something that you learned a while back, 8th grade math, that over here on this triangle, we call this leg A. And on the bottom, we call that leg B. Now, they're the legs because they touch the right angle. And they are the two shorter sides of any right triangle. Now, opposite of this right angle is our longest side of the triangle. And we call that the hypotenuse. In order to write an inequality, you need to understand this concept, right? That these are legs and this is the hypotenuse. And the hypotenuse is the longest side. Now, with this being said, we can take this idea to help us form the inequality using these two terms, right? This right here, well, the single term, that's 9, and this expression we have. Because think about it. This A side, right, which is a leg, so I'm just going to write it out as a verbal statement, leg A, right, must be less than the hypotenuse, the longest side of the triangle. Now, if I look back at this image, if this is a right angle on the left, it also makes a right angle on the right. And across from it is my hypotenuse. So when I write my inequality, I'm going to take my leg value, in this case it happens to be 9, put it on the side where the leg is, and that's going to be less than the hypotenuse, which is x minus 22. Now we want to go ahead and we want to solve this. So I'm going to treat this just like if it's an equation. I want to get x all by itself. So I'm going to add 22 to both sides. That cancels it on the right. And then this is going to become 31. And all that's left now is our x value and our symbol. Now I'm going to kind of treat this like a pancake. I'm going to take this and just flip it around, because I like the x to be on the left, and I'll say x must be greater than 31. Now we're going to do one more. Let's say that we did the opposite. Let's say we said 9 is greater than x minus 22. Same thing, I'm going to add it to both sides. And what we're going to do is, once I get done with this, we're going to see which one of these makes most sense. So I'm going to bring down the x. And again, this is going to be 31. So we have two situations. We could say that x is greater than 31, or we could say that x is less than 31. But only one of these can be true. Now keep in mind that our leg has to be less than the hypotenuse. It has to be. So what we can do is we can just substitute this value into x and see which one is actually true, which one makes it less than a hypotenuse. So for instance, I want you to think about this. I'm going to rewrite this statement over here. So I have 9 on the left. So now we're gonna kind of try this idea. In this first one, right, we said that x had to be greater than 31. And so let's make x greater than 31. So a number greater than 31, 32. I'm just going to keep it really simple. And what I'm going to do is replace this x with a 32, and then I'm going to put minus 22. And if I were to subtract this out, 32 minus 22, that would leave me with 10. So my statement is 9 is less than 10. And that's correct. This shows that my hypotenuse is larger than my leg. So this is the answer that I would want to use. So it's going to be x is greater than 31. I'm going to box it real quick. Now notice, right, I said we could have done it the other way. We could have flipped the sign around, right, and we could have said x is less than 31. But let's see what happens when we take a number less than 31 and we substitute it into our inequality. So I'm just going to put a little box here. So I'm going to go ahead and put 9. And in this case, right, we have our less than symbol. And I'm going to put a number less than 31. So I'm going to put 30. And minus 22. So then I have 9 is less than 8. So is this true? Is 9 really less than 8? And it's not. It's false. So we know for sure we're not going to use the one that says x can be less than 31. Because then we have a situation where the hypotenuse is actually shorter than the leg. And we can't do that, right? The hypotenuse is the longest side of the triangle, and so therefore we have to use the answer that makes sense.